Hello everyone, and welcome to this lecture of NFPA 30, the Flammable and Combustible Liquids Code. This presentation introduces NFPA 30, the primary fire code governing the storage, handling, and use of flammable and combustibles, which is now called ignitable liquids. With recent updates and a legacy dating back to 1913, NFPA 30 remains essential for reducing fire hazards in industrial, storage, and commercial occupancies. My name is Captain Engineer Salman Salah Al-Buflasa, and I'm a Certified Fire Protection Specialist. The origins of NFPA 30. In the early history, in 1913 till 1957, it originated as the suggested ordinance for the storage, handling, and use of flammable liquids. NFPA 30 started as 1913, but from 1913 till 1957, it served as a model law for local authorities. But in 1957, it became a formal NFPA code, keeping most of its original content. Over the years, new industrial hazard led to major changes. For example, in 1984, it removed service stations rules, which is now an NFPA 30A. And in 1990, it added requirements for storage lockers, ventilations, and emissions control. And skimming to 2000, the year 2000, it introduced vaulted protected tanks, non-metallic intermediate bulk containers, or the IBCs, and process building rules. In 2003, it added occupancy definitions to align with NFPA 1, 101, and 5000. And in 2008, it reorganized and introduced chapters 9 to 16 on control areas, MAQs, and protection levels. Continuing the development of NFPA 30, and 2015 it set a 12 feet storage height limit for mercantile occupancies and adopted tank security rules. In 2018, it recognized fire-tested non-metallic intermediate bulk containers and allowed unlimited protected storage when criteria is met. In 2021, it introduced the term ignitable liquids to replace the old flammable and combustible system, making classification simpler. And finally, in 2024, it moved unstable liquid content to NFPA 400, added new annexes, and introduced flame mitigation devices. So, in summary, NFPA 30 grew from a simple ordinance into a comprehensive, data-driven code that reflects today's understanding of a flammable liquid safety. The contents of NFPA 30. NFPA 30 is structured so that each group of chapters addresses a specific stage of liquid management. For example, Chapter 1 through 7 apply generally to any facility storing, handling, or using ignitable liquids. And Chapter 9 to 12 covers storage in containers, portable tanks, and IBCs by occupancy type. Chapter 13 addresses detached and protected buildings, while Chapter 14 covers hazardous material storage lockers. And Chapter 15 governs outdoor storage, and 16 detailed fire protection design. Chapter 17 set design and construction rules for process and use facilities. Chapter 18 covers handling, dispensing, transfer, and use of solids, liquids. Chapter 19 focuses on specific equipment and operations. And Chapter 21 to 25 governs bulk storage tanks. And Chapter 26 adds requirement for petroleum production sites. And 27 till 29 covers piping systems, loading and unloading facilities, and wharves. Knowing this helps move from general principle to detailed technical applications, and it will make everything easier when you open the code. The retroactivity and equivalency. NFPA 30 is primarily forward-looking. Its provision do not automatically applies to existing installations or facilities, which is approved before the current edition unless a serious or a threat hazard exists. However, the AHJ, or the authority having jurisdiction, may enforce retroactive measures if the existing condition presents unacceptable risk for us. And the AHJ can also modify retroactive requirements when strict application is impractical, but equivalent safety measures can be shown. And for equivalency allows alternative designs, system, or devices that offer equal or superior protection. Chapter 1, Administration. The applicability. NFPA 30 shall apply to the storage, handling, and use of ignitable, which is flammable or combustible liquids, including waste liquids, as heard and defined and classified. It serves as a mold regulation intended to minimize hazards from flammable and combustible liquid while supporting safe commerce and industry. So NFPA 30 serves as a model code. Compliance minimized but does not eliminate all risk in handling such liquids. The 2021 edition introduced the term ignitable liquids to unify consistency. Ignitable liquids includes all liquids with measurable flash point, establishing a consistent flash point-based system. The older term remains temporarily for transition, and liquid now means ignitable liquid unless otherwise specified. But also there's always an exemption. NFPA 30 shall not apply to the following: any liquid that has a melting point of 100 Fahrenheit, 37.8 Celsius or greater, any liquid that does not meet the criteria for fluidity given the definition of liquid in Chapter 3 and the provisions of Chapter 4, and any cryogenic fluid or liquefied gas as defined in Chapter 3, since they both, one is in NFPA 55 and the other is in NFPA 58. And any liquid that does not have flash point yet is capable of burning under specific conditions are also excluded. Any aerosols, mist, spray, and foam are outside the code scope. And transportation of ignitable liquid is governed by the U.S. Department of Transportation, the DOT, and not by NFPA 30. And the use for alcohol-based hand rub dispensers that comply with NFPA 101 or the adapted fire code, as well as liquids contained in the fuel tanks of vehicles, aircraft, boats, and stationary engines. And also liquids that show no fire point when tested up to their boiling point is also not covered. Water-based liquids with over 80% non-combustible content that do not sustain combustion during standardized tests are also exempt. Finally, unstable liquids that prone to violent reaction are managed under NFPA 400 instead. These exclusions allows NFPA to focus strictly on real ignitable liquid hazards. Chapter 3 definitions. Here we have several key definitions. For example, alcohol-based hand rub means an ethanol or any solution up to 95% concentration designed to reduce microorganisms on hand. And a control area is a defined portion of a building where ignitable liquids are stored or used within the maximum allowable quantity limits. And a fire area is a section of a building separated from the rest by construction having a minimum of 1 hour fire resistant rating. And a barrel is what is equivalent to 42 gallons or 159 liters. And the boiling point is the temperature at which the vapor pressure of a liquid equals the surrounding atmospheric pressure. The fire point is the lowest temperature at which a liquid will ignite and sustain burning, and the flash point is the minimum temperature at which it produces enough vapor to form an ignitable mixture with air. And now here we have the key definitions for us. A flammable liquid refers to an ignitable liquid of class 1. A combustible liquid refers to an ignitable liquid of class 2 or 3. And ignitable liquids means any liquid with a measurable closed cup flash point. A stable liquid will not react violently or decompose at a normal pressure and temperature. An unstable liquid can decompose or explode when subjected to heat, shock, and pressure. A water miscible liquid mixes completely with water in all proportions. And a hazardous material storage locker is a prefabricated or ready to assemble outdoor unit designed for code compliant storage of hazmat. These definitions lay the groundwork for every chapter that will follow. And this is just a description of the class 1 liquids and the sub-classifications. And we can see clearly on the right, the lubricating oil for class 3B, the pine oil for class 3A, a jet fuel for class 2, and class 1C is xylene, and class 1A is pentane, and 1B is ethanol. So it shows clearly the boiling point and the rate vapor pressure. Let's go back again. So class 1 liquids, they have flash point below 100 Fahrenheit, which is 37.8 Celsius, and vapor pressure not exceeding 40 pounds square inch at 100 Fahrenheit. And it is subdivided at class 1A, flash point below 73 Fahrenheit and boiling point below 100 Fahrenheit, and class 1B, flash point below 73 Fahrenheit and boiling point at or above 100 Fahrenheit. And we have the class C, flash point at or above 73 Fahrenheit, but below 100 Fahrenheit. And we have the class 2 liquids with a closed cup flash point at or above 100 Fahrenheit, but below 140 Fahrenheit. And class 3, the liquids with a closed cup flash point at or above 140 Fahrenheit. And we also have this sub-classification for class 3, which is class 3A and class 3B. One is flash point at or above 140, but below 200 Fahrenheit. Flash point at or above 200 Fahrenheit. So as flash point increases, fire decreases, but storage and handling precautions remain required for safety compliances. And class 4, we have chapter 4 is have classification of liquids. And this is just a diagram explaining the differences between the all classes and the difference of temperature between the combustible and the flammable based on the flash point temperature. And a key point here for defining the boiling point, atmospheric pressure shall be considered to be an absolute pressure of 14.7 pounds per square inch or 101.4 kilopascal. And chapter 6. Chapter 6 of NFPA 30 focuses on preventing the ignition of vapors and escalation of fires. It also established methods to identify, evaluate, and control fire and explosion hazard throughout management, analysis, and prevention. It requires engineering evaluation when handling liquids above flash point, exceeding maximum allowable quantities, or involving class 1 materials. It requires facilities to identify potential ignition sources, such as open flames, electric sparks, hot surfaces, and static discharge. And also proper ventilation, bonding, and grounding is essential when transferring or mixing ignitable liquids. Static electricity must always be controlled, especially during pouring, pumping, or any operations. And also this code also references related standards such as NFPA 68 and 69 for explosion prevention and venting, and provides guidance for detection, alarms, and fire suppression systems using NFPA 13 and 750. And it also guides housekeeping, leak control, and immediate cleanup of spills, which is critical. And employees must be trained to recognize the hazards and follow safety procedures. So in short, this chapter ensures all the practical measures that is taken to stop fires and explosions before they begin. Chapter 7, Electrical Systems. The scope of Chapter 7 applies to all areas where Class 1 liquids are stored, handled, or used, and where Class 2 and 3 liquids are used at or above their flash points. Electrical system presents one of the most common ignition sources in ignitable liquids operations. So Chapter 7 mandates that all electrical installations must comply with NFPA 70, the National Electric Code. Areas where flammable vapors may exist are classified as Class 1, Division 1, or Division 2, depending on the frequency of vapor presence. And also all wiring and fixtures within this zone must be approved for hazardous locations, and static grounding, bonding, and spark-proof equipment are vital. So this ensures that a single electric arc cannot ignite vapors or gases released during normal operations or accidental leakage. So proper design of lighting, switches, and control forms of the foundation of electrical safety should be correctly installed based on NFPA 70. Chapter 9, Fundamental Requirements. Chapter 9 sets the general requirements for storing ignitable liquids in containers, portable tanks, and IBCs. It also established how storage areas should be separated based on the quantities limited per area and required fire resistance of barriers. And also liquids must be stored in approved containers that meet construction and testing standards such as UL or DOT requirements. And also the spill containment, drainage control, and separation from incompatible materials, which is mandatory. And also this chapter also connects storage design to protection levels, such as sprinklers, cabinets, and control areas, ensuring a clear link between hazard level and fire protection design. So in general, NFPA 30 specifies strict construction capacity limits for containers and portable tanks. Metal safety cans, non-metallic containers, and IBCs must all be listed and labeled by an approved testing organization. And non-metallic containers are allowed only when tested for resistance to static discharge and chemical compatibility. So yeah, this chapter ensures all that even the small storage unit can withstand heat, fire exposure, and accidental impact without catastrophic failures. But more stringent requirements are set forth in Chapter 10 through 14. These requirements shall take precedence, and means of egress shall meet applicable requirements of NFPA 101. Now we have the maximum allowable quantity and control areas. NFPA 13 introduces the concept of maximum allowable quantity, or MAQ, just like NFPA 400, which limits how much ignitable liquid can be stored within one control area of a building. These limits vary depending on the class of liquid and whether the area has a sprinkler protection or approved safety cabinets. But when MAQ is exceeded, additional control areas or higher protection levels must be provided. This system prevents excessive fire loading in a single compartment, and ensures that even if a fire occurs, it can be contained by the design of the building and its suppression system. And for the MAQ table 9.6.1, as a summary, MAQ may be increased by 100% when liquids are stored in approved storage cabinets or safety cans per the fire code. And MAQ may also be increased by 100% in buildings fully protected with automatic sprinklers based on NFPA 13. MAQs for Class 1B and Class 1C liquids may be increased by 100% for consumer products, beverages, medicine, cosmetics, and applies only when total quantities of Class 1A, 1B, or 1C liquid do not exceed the MAQ per control area individually. And for Class 3B liquids, quantities are unlimited in buildings fully sprinkled and designed per Chapter 16 protection criteria. And as a final note, increases from notes 1, 2, and 3 may be applied cumulatively, allowing significant MAQ increase when all conditions are met. And we have the special occupancy limits. For the following occupancies, the MAQ per control area shall not exceed the amount specified in Table 9.6.2.1, which is the assembly occupancies, ambulatory healthcare, businesses, daycare, detention and correctional, education, healthcare, and residential. So the MAQs in Table 9.6.1 also applies to Class 1B or Class 1C when used for beverages containing 50% or less ethanol by volume in water, and applies only to containers equal or less to 99 gallons, which is 3.785 liters, intended for assembly or business occupancies. As for the control areas, as we mentioned before, a control area is a defined space within a building where ignitable liquids are stored within the MAQs listed in tables 9.61 and 9.621. Multiple control areas can exist within one building, but each must be separated by fire-rated construction, and the fire resistance rating depends on the floor level and number of control areas, as shown in table 9.7.2. So as you move high in the building, the permitted MAQ decreases. So, in simple terms, the lower you go in the building, the more quantity can be stored. The higher you go, the stricter the limit becomes. And these are the rest of the chapters. Chapter 10 for storage of ignitable liquids and containers for mercantile occupancies, and Chapter 11 for industrial, and Chapter 12 for storage, and Chapter 13 for detached unprotected buildings, and Chapter 14 is for hazardous material storage lockers, 15 for outdoor storage, until we get to petroleum production sites. So this concludes